So we're going to find dg dt evaluated at t equals -2 for g of t is equal to t squared plus 1 over t squared minus 1. Okay, so here we see that we're actually going to use, since we see a fraction, we're going to use the quotient rule. Okay, so quotient rule on this one, in contrast to the product rule, one that we saw on the other example. Okay, so for this one we have to identify what's the top. So this is going to be our u, and this is our v. Okay, so the top is all u, that's high, and then the v is the low function. Okay, so let's refresh. If you're doing g prime of t, that's going to be the same thing as u over v, and all of that we're taking the first derivative of. So what we're going to do is write down our little like ditty. Okay, so low d high, so low is v, d high is u prime, less high u, times d low v prime over low squared, with low squared below, right? So in function form, this looks like g prime of t is equal to low, so we're going to write down t squared minus 1, because that's directly from the bottom, times d high, so we're going to do d dt, and we're not doing d dx here because we're not dealing with x's, right? So we have to differentiate with respect to t. So d dt of the top of high, which is t squared plus 1, okay? And then we have minus that less sign there, high d low. So high is t squared plus 1, and d low would be d dt, again, of whatever's on the bottom. So t squared minus 1, okay? And then this is all written over low squared below. So t squared minus 1, quantity squared. Okay? Alright, so let's continue simplifying here. I think I can squish in one more line down here. So we have our t squared minus 1, and d dt of t squared plus 1 is going to be, that plus 1 is going to go away. It's going to go to 0, right? And then we bring this 2 down in front, and we have a t left. And then we have minus, I'll just draw a little line here so we don't get confused. Okay. Alright, so minus t squared plus 1, and then times the derivative of t squared minus 1, so that again is going to be a 2t, okay? So then on the bottom, don't forget that we have this t squared minus 1 quantity squared. Okay, so let's, I'll copy this last line down here on the next slide, okay? Alright, so far we have found that g prime of t is equal to t squared minus 1 times a 2t, and then minus, or less, t squared plus 1 times a 2t, okay? And this is all over a t squared minus 1 squared. Okay, so if we continue, as I said, this is going to be, if we distribute that in, we get 2t to the third minus a 2t, and then we have minus a 2t to the third plus a 2t. Okay, so what are we going to do with this? We're just going to keep copying down the bottom there. That's just kind of hanging out down there. And now when we factor in, or sorry, I always say factor. When we distribute the negative sign, on the next line we'll get a 2t to the third minus a 2t minus a 2t to the third minus another 2t, all over t squared minus 1 squared. T squared minus 1 squared. Yeah. Okay, so then this is going to be g prime of t is equal to, so we see the 2t to the third plus, and the minus 2t to the third, those ones cancel, and these negative 2t's combine to make a negative 4t on the top. So what we have is a negative 4t over t squared minus 1 quantity squared. Okay, so this is our g prime of t, also known as dg dt. Okay, and this is not what the question was asking for. The question asked for this thing evaluated at t equals -2. Okay, so let's plug it in on the next slide. So if we know that dg dt is equal to negative 4t over t squared minus 1 quantity squared, when we do dg dt evaluated at t equals -2, that's just going to be the same thing that we see here, okay, except we're going to plug in that -2, all right? So when we do that, we get -2 squared minus 1 quantity squared, and then on the top we get a positive 8, okay? And then on the bottom we get a positive 4 minus 1, so that would be a 3, and then squared, so that would be an 8 over 9, okay? So our final answer the derivative of g evaluated at t equals negative 2 is going to be 8 over 9.